Okay, so in here we're going to be looking at the second aspect of the design, and we're looking at controlling the variables. And so I've again put out a detailed list on what you need to do to get your 2 marks for this. So it's just a matter of following this through. So you need a list of apparatus used. This needs to be a comprehensive list, and you should really draw a label diagram of the apparatus. And as I said here, a photograph is a good idea, but it could well be done by hand. Make sure that you use a ruler. It needs to be detailed and fully labeled. Now, just to highlight this, I'll go back to the example and highlight a couple of points on that regard. Here we have our list of apparatus for this design. We've got a tennis ball stand, meter ruler times 2 table. Now, it's not necessarily a comprehensive list of things. I mean, what's holding up the ruler here? Is there some sort of clamp? Has that just been held up by itself? You make sure that this is really detailed. Now, in drawing the diagram, as you can see here, this is really a poor diagram. I made some points here. You should use a ruler. It should be accurate. And most importantly, you should show where the independent and dependent variables will be measured from. This really helps when explaining the prac. So I've redrawn the diagram below here in hopefully a manner that will show you what I mean. So here we've got it drawn. It's obviously drawn with a ruler. It's been scanned and put in there. There's straight lines here. This ruler is at 90 degrees to the floor, and you can see that. And most importantly here, I've really labeled where you're going to measure the ball for the independent and the dependent variable. That's really important to do. So it's showing where the measurements will be taken from. Okay, now going on with this, going back to my checklist over here, you need to describe how you're going to change and measure the independent variable, and then describe how you're going to measure the dependent variable. Now, this needs to be done in a detailed description, and here I would encourage that you do it in point form. You need to be able to do it so that others could repeat exactly how you measured this quantity. So it's got to be done in a step-by-step way of how you are going to change and measure both the independent and the dependent variable. And then followed after that, you need to describe what you did to make sure that the controlled variables remain constant. So each controlled variable that you have mentioned needs to be included as to how you attempted to achieve this, keeping it constant. So these are really important for you to go through this in a systematic way. So going back to this diagram over here, I have got a description of this. You can't just say measure the rebound height or release the ball from a certain height which is measured using a ruler. You've got to be really detailed. For instance, I've stated over here, the height of release will be measured by a meter ruler from the floor to the bottom of the ball as seen in the diagram. When doing this, care must be taken to ensure that the error of parallax is minimized. And again, we do the same for measuring the dependent variable. A marker pen will be used to mark on the meter ruler the height that the bottom point of the ball reaches. So showing exactly. Now, this we will come back to later. This should be left to later, telling the different values that will be done. First, we need to continue and go on to doing the controlled variables, manipulation of the controlled variables. So you must state here, as I said here, must state which controlled variables are being considered and how you kept them constant. Alright, so i.e. the ball will be dropped and therefore the initial velocity will be kept to 0. Okay, so that's basically that part of it. I think I will try and get into the next part of this, the aspect 3. This over here, see if I can do this all in one video. Here we need to just state the range of values of the independent variable that you're going to use. So in doing this, you would usually want to change this a minimum of 5 values that would be changed. Now you need to be specific in this. Doing more is better, and there's no reason why you shouldn't do more. 6, 7, 8. Rather do more. You may not even have to do this yourself. You may not even be able to be taking all this data. And make sure you have a good range in relationship to the situation that you're dealing with. As it says, your readings should be a reasonable spread across the range. Don't cramp them up all into just a few right in one place, but spread them over a good range. And then state how many times you are going to repeat the measurements of the dependent variable. There should be a minimum of 5 readings for the dependent variable for each of the independent variables to improve accuracy. Sometimes this doesn't really work, and then you may want to take a greater number of independent variables and only one of each, and you should do at least 25 of those. I can talk to you about that when you're actually doing the lab. So just going back to this, here this student has done it quite well here. They've done it here. The values of the initial height are 1. See, it's being very specific. Good to state the actual values that will be taken. This person's actually chosen 1, 2, 3, 4, 5, 6, so that's good. But then it's all mixed up with the method. Rather have this at the end separate. And then here, going down, if we go down here, go down over here. So as I've said here, the range of the independent variables and the number of repeat trials should come at the end of the design lab. So where is it here? Oh, here it is. It says repeat these steps 7 different times. That's fine. 5 trials will be made for every initial height. So that's fine, but it should be down at the bottom here. Alright, so set it out clearly and accurately. Follow the rubric that I have given you here. Come and talk to me when you don't understand something. Thank you very much.